Hello everyone and welcome to my channel where I post app development tutorials. In today's clip, we'll cover 5 basic things about some of the building blocks in Swift, mainly variables, constants, and data types. For the practical part of this tutorial, we'll be using Xcode. So if you don't have Xcode or if you feel a bit lost in this clip, please check my previous tutorial link somewhere over here. And with that, let's begin. Okay, number one, what are variables and constants? So in any program, in any app, simplistically speaking, we need to keep track of pieces of data. So for instance, in the Instagram app, we need to keep track of things like user profiles, users, obviously images, the number of likes an image has, etc. To do so, in Swift, we use variables and constants. So pretty much we use variables and constants to refer to such pieces of data. In other words, they're pretty much named containers that are used to refer to objects. Number two, what is the difference between variables and constants? Now, variables are supposed to vary and constants are hence the name. So pretty much when you store something in a variable, you're telling the program, hey, this piece might change in the future throughout the cycle of the app. Whereas then when you store it in a constant, you're telling the program, hey, this piece will remain the same, it will not change throughout the cycle of the app or the cycle of the program. Some good constant examples are your birthday, the number of pi, the number of minutes in an hour, the number of seconds in a minute, etc. But to put this into context, let's think of a fitness app, an app that among other things allows you to convert walked miles into feet and allows you to record fitness goals along with other features. So for the conversion part, to convert miles into feet, it uses the equation miles times 5,280, and that gives you out the number in feet, the same value in feet. So for the miles, that one we're supposed to store in a variable because it's going to change. Whereas in the conversion factor, the 5,280, that part is stored in a constant because it's not supposed to change. And that takes me to point number 3, what are data types? Number 3, what are data types? So what else do we know about the values provided in the previous example? We know that both miles and feet are numeric values. And we also know that the fitness goals are textual values. So in programming, these kind of types are known as data types. And both variables and constants have data types associated with them, with each data type having its own unique characteristics and its own unique abilities. Now, there are various types of data types in Swift, but the most common built-in data types in Swift include strings. This is pretty much the equivalent of plain text in English. We also have ints, int, and these are used to store whole numbers, and we have double and float. These ones are used to store numbers that have a fractional component in them, with the main difference being is that doubles are 2 times the precision or have 2 times the precision of floats. And we also have bool values. These ones are used to store true-false values. Other more complex data types include arrays and dictionaries. These ones are used to store collections of objects. So whenever you want to store a list of items, you would use either dictionaries or arrays. Arrays are used to store ordered items, and dictionaries are used to store key value pairs. And that was the list. It's not a comprehensive list, but it's the most common built-in data types. Swift also allows you to build in your own custom data types, but more on that in future episodes. So for now, before going and delving into further theoretical knowledge, let's go ahead and apply what we've learned so far. So let's go ahead, open up Xcode, open up a playground, and we'll apply what we've learned so far. Okay, so we're back at the station, and we have an open playground. This is where we left off last time, so let's go ahead and create some variables and constants. Now, looking back at the values we mentioned earlier, the ones from the fitness app, the conversion factor and the walked miles, to put those values into data containers, we need to follow 3 simple steps. Step number 1 is we need to declare those variables and constants. So both variables and constants need to be declared before they can be used. And what this does is it just sets aside a piece of memory that's supposed to be used by either the variable or the constant. And to do so, we use the var keyword for variables, and we use the let keyword for constants. So I'll go ahead without further ado and let's put this into test. And I'll just quickly type in a quick comment, variables and constants, just because I like having headings above snippets of code. Okay, variables and constants. So we'll start with the constant that we had was the conversion factor. So we'll start with that one, and I'll type in let. It's one word in lowercase. And then what I need to do is I need to choose a meaningful name. So for our case, I can choose conversion factor, or I can say miles per 1 feet or miles per feet, whatever makes sense to me. So I'll choose conversion factor just because the purpose of this constant is to convert from miles into feet. And then once that is done, next step is second step is initialization. And that is giving an initial value or assigning an initial value to the constant in hand. And to do so, we type in the equal sign as so. And if you recall, for conversion factor, we said it was supposed to be 5,280. So this will be my assigned value, 5,280. Voila. And as you can see, you should be able to see the output on the right side of the screen. If you can't see the output, just make sure that this bar isn't too narrow. Make sure it's big enough to display the output of the code. Okay. So that was the constant. Now let's go ahead on a new line and create a variable. So for one of the variables that we had for our fitness app was the walked miles, the number of walked miles. So I'll go ahead and I'll type in var, once again in lowercase. And once again, I need to choose a meaningful name, so I'll just go with walked miles. Okay. And then space equals sign, and I'll just give it an initial value of 0 for now. Okay, and once again, you should be able to see the output on the right side of the screen. Now you'll notice that I typed or I declared the variable on a new line. And that is because this over here, this command over here is statement, the one that declares the constant. And this one over here is another statement. And the way it works in Swift is you need to have line breaks between each statement. I can delete the line break, but to do so, we would need to add a semicolon. And the more conventional layout is to just split these statements with line breaks. Now, this is an example of syntax. Syntax is pretty much the structure or the grammar of the programming language. Another example of syntax would be, if you take a look at the string over here, it's surrounded with quotation marks, and that's because the quotation marks indicate having a string. So that's another example of syntax. Another example of syntax is if I were to delete this over here, if I were to delete the space preceding the equal sign, it's going to give me a compiler error, a syntax error, if you may. And that's because it has to be consistent. So if you have a space preceding the equal sign, you need to have a space following the equal sign. And if you don't have a space preceding the equal sign, then you guessed it, you shouldn't have a space following the equal sign either. It has to be consistent. Okay, I'll just put the spaces back. So that was in regards to syntax. Now, in regards to choosing variable or constant names, There are a few rules and tips to keep in mind. Rule number one is it has to be one word. So I can't split, let's say, conversion factor into two words. It's not going to work. So it has to be one word. Another thing is it's case sensitive, and Apple suggests going with the camel case format. That is having the first word of the first word of the name. Each word has to start with a capital letter, except for the very first word. So over here, conversion factor is capitalized, but conversion isn't, and that's because it's the first word. If, let's say, it was, let me try and come up with a more complicated name. So miles per 1 feet, it would be miles and then per 1 feet. Each word is capitalized except for the first one. Okay, now when it comes to going with camel case format or choosing meaningful names, now these are tips, so your code won't break if you don't follow these conventions. It will surely compile, but it will be easier to read if you follow these conventions. And I'll add a link to a more comprehensive list of tips and guidelines for selecting proper names. Okay, so that was it in regards to choosing names and syntax. Now let's go ahead and try and alter this variable and this constant. Now remember, we said variables vary and constants don't, so let's give this, let's put this into test. So I'll start with conversion factor. It's a constant, so technically we shouldn't be able to alter this value. And I can alter it using arithmetic operators, so multiplication, subtraction, addition, any of these. And I'll choose addition, so I'll go 7 plus 7, and technically it shouldn't work. And voila, indeed it gives me an error, and it says cannot assign to value. Conversion is a lit constant. Pretty much is saying this is a constant, so if you want to change this value, or if you want to alter this value, change it into a variable. Okay, let's do the exact same thing with walked miles, and this time it should work. And indeed it does work, and you should be able to see the output on the right side of the screen. This protects the code or the constant from you, the programmer, having you, the programmer, accidentally overwriting the value. So if, let's say, you have a value that absolutely won't change or absolutely shouldn't be changed, go with a constant. Another benefit from us using constants is if, let's say, this value over here changes for whatever reason, let's say the metric standards change or something, you can just go to one spot and change that value instead of having to jump into multiple spots across the code and changing that value. Okay, so that was it in terms of the main difference between variables and constants. So let's go ahead and create another variable, and this time we'll discuss the third step involved in creating variables and constants. So remember, we had another variable from that fitness app, and it was the converted miles into feet, so walked miles but in feet. And I can choose, I can say walked miles in feet, or my walked miles converted into feet. I'll just say walked miles in feet for now. Unlike the previous variable and previous constant, I'm not going to assign this one an initial value, but what I'll do is I'll assign it a data type, because it needs, right now it's complaining it's missing part of the pattern. It needs to know what kind of value is going to be assigned to it. Is it a string of characters? Is it an integer? Is it a double, a bool? What is it? So what I'll do is I'll assign it a data type, and to do so you just type in a colon after the name, follow it with space, and then type in the type. So I'll choose double, so double, and voila, right now we have a declared variable that has a type of double, a double data type. Now, in case you're wondering as to why with the conversion factor and the walked miles, it didn't complain about the lack of data type, whereas then over here it did. And that has to do with point number 4 in today's tutorial, and that is type inference and type checking. Swift is a type inferred language, meaning that when given a value, it can automatically deduce the type of data type, or what kind of data type is it. So for instance, with conversion factor, it was able to look at the number over here on the right side of the equal sign and automatically figure out that this is a number. Same thing with walked miles. With the string over here, was it checked the quotation marks, and it was able to automatically deduce that this is a string. Now with the walked miles in feet, remember I didn't assign a value, and therefore it had nothing to look at for it to know what kind of data type is supposed to be associated with this variable. So I had to explicitly define it. Now let's go ahead and give it an initial value. So I can go equal, I can give it a 0 for now. But what if I were to make a mistake and let's say give it a string? So let's give that a text, and it should complain. So it complains, and the error says cannot convert value of type string to specified type double. So you need to make sure that the value assigned to a specific variable matches the data type associated with that variable. And the same thing applies for implicitly defined data types. So if let's say I try to alter walked miles and give it a value of a different data type, so for example text, it's going to complain because it has already been assigned a 0, which is a number, so it was implicitly given the end data type, and now I'm trying to give it a string, so it goes like, wait, is it a number, is it a string? And it goes with the number, because this one, this was the initial value assigned to it, so it gives me the exact same error. Okay, so I'll delete this for now, and I'll fix this one. Now I can give it an initial value of, let's say, 0, but what if I want to design the app in a way so that when there are no walked miles, the variable would have no value associated to it whatsoever, like blank. So not a 0, not a space, nothing, nada. And this takes me to point number 5 in today's tutorial, and that is optionals. So sometimes you have variables that are supposed to have a value associated to them throughout the cycle of the app. So more like mandatory fields and forms, they can't be blank. And sometimes you have variables that are supposed to be blank at some point throughout the app. So they shouldn't have a value associated to them whatsoever. Like I said, not a 0, not a space, nothing, nada. And the no value equivalence in Swift is nil, N-I-E-L-S. So now, if I were to try and associate a nil, it's going to complain. So let's give it a step. So it gives me an error, and it says nil cannot initialize specified type double. To fix it, you need to add a question mark. So what the question mark does, if I were to follow this suggestion, it's gonna convert this variable into an optional variable. And that is because by default, all variables and constants in Swift by default are non-optional fields. So what the question mark over here does is it converts it into an optional field, and as you can see on the right side of the screen, it associates a null. And by default, it would take in a null. So if, let's say I were to delete this, the initialization part, and all I have is the question mark, it would still assign a null to it by default. Okay, So that was it in regards to optionals, and that's it for today's tutorial. Thank you so much for watching. If you have any questions, please let me know in the comments below. And if not, I'll see you in the next episode where we'll cover control flow and we'll also delve a bit more into data types. Until then, have a wonderful day and see ya. Bye-bye. They can have the minus sign